Hi everyone, and welcome to Practising Programming in C, where we're going to continue with our adventures in multi-threading. We're going to try and consume jobs from our job queue that we created in yesterday's stream. So let me put some music on and then we can begin. Let's at least get, what was this, 2011? Oh, they're both on the same day, that's nice. There was actually no anniversaries today, the 15th, so it's going to be stuff from yesterday, PJ Harvey and Tim Hecker. An hour and a half, that might be the stream. So what we've got is this function here, and what this function does is it takes input like so, and upon pressing enter it writes that input into a database, and upon writing that input into the database it prints out the job queue. In addition to that, we have this threading test directory which we are watching, and if we were to make a file containing some important information and then save that file, we'll see that has come through to this program up here, and it has added another job onto the job queue. So the distinguishing thing between these two jobs, the first one is just called a UI job, which is basically like, you know, interacting with this, user interacting with this, and this is the thing that they put into that box up there. And this job, this file IO job, is to do with file system events, and it's saying that this file name is 38 bytes long. That's all it's saying. Now, the files in question are these two. These are where they've written the information to. So we just wrote a file, didn't we? So that a file is here, and this is going to be its size 26 in hex, which is going to be 38. Like so. And the other thing was the UI file, wasn't it? And with that one we wrote the input. So there's input there. Is that going to be that? Maybe, probably. Yeah, it probably is that. Okay, so we've got these two different files, and the point of the job queue is to actually have a single thread able to take these two sets of imports and to write a single database. So instead of having two databases, we'll just have a single database. So that's all we're doing. That's all we're doing today. We're just taking those. We're just taking these jobs and dealing with them. This was just some notes for Cinera that I was doing earlier. So take job is the function we're dealing with. isn't it? Yeah, it will be that, yeah. So we're going to have a thread, aren't we, who's like the consumer. The job taker. Let me just see what we've got actually. So yeah, we've got the center, the reference point, and the user interface threads. Oh yeah, I suppose I should also mention that the reference manager function is this. So that has just sent an instruction to this program. So that's another part of it, but we don't actually have this doing anything interesting in terms of stuff that we can put into a database. So I'm just not doing that for now. So yes, I think I need to make a it's just like a generic consume job function. And all this is going to do, it's going to first of all check if there's, so this is the thing, right? We've got this queue that we're going to be looping over essentially. And the queue has within it indices. So the next job to take is the one that the consume jobs is going to be talking about. Now, there might not be any jobs in the queue. So what do? Do you just sort of sleep and then wake up and see if there's a job in the queue, and while there isn't a job you just sleep? I don't think you do that. I think what I want to do is to use a conditional variable. So the conditional variable will be queue is like, what's the word? Not occupied. The queue is populated, or there are jobs waiting. So the consume jobs function will basically check, is that true? And I think what happens with that conditional variable is that if it isn't true, it'll just sit on that line and it won't proceed. But as soon as that becomes true, it will be able to proceed. So let me just write that out. And this next job to fill mutex, sorry, the next job to take mutex might actually just be, it might just be the conditional variable, honestly, because I don't think we'll need this mutex. Cons T looks like it. So yeah, jobs. Populated. Well, it does not matter. We just need something. Let's just stick it at the bottom. Yeah, just look at that. So this is going to start it out at null. So the first thing this guy wants to say is yeah, I wonder how the loop is going to be here. I mean, it is going to be a loop. No, sorry, it's you need to do something, don't you? I think. Yeah, cond wait. Yeah, there is supposed to be a mutex as well, so I'm not exactly sure what I'm going to do for this. Might just pass null for now, but it might come in handy. Let's make this take the job queue, maybe? What do we do with these other guys? That was the bad example. Yeah, I suppose let's just take the data. Yeah, and then modulisms. Nah, let's. It doesn't matter. The job queue. Also, it's not this, is it? I think it's literally this, isn't it? It's going to wait, and then it'll say well, I mean, this could print them, couldn't it? So these other guys who were previously printing the job queue, let's just relieve them of printing the job queue. What was that? It was only push job, yeah. So now the printing of the job queue has been deferred to the pushing of the job. Sorry, it's been deferred from the pushing of the job to the taking of the job. Now these guys, having put a job on, yeah, I mean, I sort of feel like you can do it wherever you are. That's interesting, actually. There's that mutex unlock right there, which kind of suggests that, you know, that second parameter that I can pass to the cond weight could come in. But anyway, now how do you do this exactly? Yeah, okay, it's signal, isn't it? Oh, hang on, how do you unset? Do you have to reinitialize it again? So the queue is the thing. So what does this want? Yeah, of course. Let me just take a look at the man page. What, okay, let's look at cond broadcast maybe. Oops. It unblocked all threads currently blocked on the specified condition. It shall unblock at least one of the threads that are blocked on the specified conditional variable. Signal will be sufficient because there's only one thing that's waiting on it. Okay. I'm not sure if this is how it works actually. Oh, I'll tell you what actually, if this is how it works, then this is perfect. So, how I hope this works is that the conditional variable is just, it's basically evaluating to false as a matter of course. So whenever somebody is waiting on that line, sorry, whenever somebody comes to that cond wait function, they have to wait, basically. And then when another thread does the con signal, that is a signal for that person at that time to go for it. And then the next time that other thread comes to the conned wait line, they'll have to wait again. Like the signal, in other words, like the signal doesn't persist. It's not like the signal is saying the condition is now true, therefore whenever you pass that thing it's going to be true. I hope that's how it is, because if it is, then that's solved our problem. It's alright. And if nobody's waiting, if nobody's waiting, it doesn't do anything. Yeah, I think this might be fine. Hopefully. So let us step through. I'm not really sure how it's best to let's try it. Yeah, this will just be fine. The way that I've done it, if this is how it will work. I suppose I could also, well, I can, yes, this is going to run to here, isn't it? We should see this, yeah. And then let's give it a file system event. So again, this is still running, and I haven't broken on this line. I suspect that once oh sorry, I have broken on that line. What's that? I need to continue, don't I? Ah, interesting. So we segfaulted. I suppose actually, let's just make sure they're not crashing. Yeah, okay, fine. Let's just suss out these, what's going on. Did I initialize that conditional variable? It's that mutex, isn't it? The restricted mutex. Yeah, let's just have a look at what they're wanting from this mutex. I mean, to be perfectly honest with you, we've got a mutex that we could use for this purpose, haven't we? After a fashion. I mean, it's not quite. This wasn't quite the point of this, I don't think. Oh, I don't know, it might have been. Alright, that's cool. Okay, so we're going to run to here, and then we're going to continue, and we're still waiting. But now, once I write this file, we should be able to proceed, I think. Yeah, and we did do, because it printed out the job queue. And now, well, this is perfect. having printed out the job queue, it's now just sitting on this wait again. For the purpose of sending a signal to a wait. I'll just give this a couple of... Oh shit. What's that actually done? Okay, yeah, I think we're alright. All I wanted to do was... hang on. No, sorry. Yeah, continuing. So it's yes, continuing. And it's waiting, so... I'm just a bit perturbed by it. Writing out the job queue. Let's just say that we're okay. You know, it did look, didn't it? Like it was waiting. Oh, I suppose I could break on both lines, couldn't I? That's how I could do it. Yeah, it's just waiting. It's still waiting. Oh. Right, so we're waiting. So we could try to continue once. Now isn't that weird, like when we continue for the second time, it actually does continue. Is that weird? No, it isn't, because we will have received that signal. What's happening here? I mean, we could do this sort of thing. It's a little bit tough to debug actually, because I don't know what. I suppose it's just a technique, isn't it? It's a case of learning how to do this with threads. So we've only got the one print. Did I actually build that file? I suppose we could also do this. Yeah, let's do that. And also let's just reduce the job queue size to 4, just so we can... so we can see all of them on the screen at the same time. So there we go, it's printed out the job queue once. I'm now going to write that file. And upon writing that file, that should then print out the job queue twice more, shouldn't it? It should have the job that we've just pushed, and then it should take the job off, and then it should be back to null again. Are we still running? I guess that's a question. Yeah, we do seem to be still running. That's pretty odd, wouldn't you say? Next job to take mutex. Oh, I know why. We're not getting past this. We're not getting past this because our thread is blocked on it. The consumer here has blocked on it, which is kind of interesting actually, isn't it? Let's keep that. I think I know why it's not working, or rather why it's not doing what I hoping it is to do. But let's continue to just leave it doing that, and let's just unlock that mutex. Let's unlock it. Oh, we can't. We need to unlock it before taking job, because that's the problem. That's the person who's waiting on it. So we're going to print the job queue, we're going to unlock that mutex, and then we're going to take that job, and then print the job queue again. So now, I think we should now see what we're after. Yeah, sure enough, we kind of do. We're seeing this more times than I was expecting though, aren't we? Except no, this is going to be this job queue printout. This one up here is going to be this one here. So yeah, we're now waiting on this on the next job. Who was it who sang time after time? Was it was Bonnie Tyler in my mind? Cyndi Lauper, she's the person. Time After Time by Cyndi Lauper. Perfect, so this is working exactly as I would hope. Take the job. Now, as I say, this mutex here is kind of a bit of a waste of time because we only have one consumer. So really we can just we can just not bother with the mutex in here. And then, I mean, to be honest with you, not bother unlocking it here. And now we should get the same behaviour. And also, just before I do that, it might be handy just to print the function here, just so we know where we're at. So there we go, consume jobs. So they're waiting. Yeah, so it managed to take the job, I reckon. Yes, we did take the job because it's back to null. Now, an interesting thing to note here is that I reckon, we didn't spot it before, but I think the next job that we push on should be in slot 1. Yeah. And then it should be in slot 2. Let's just go through all the things. And then slot 3, and then should be back to slot 0. Yeah. Fancy that. So the take job function, I mean, we're totally cooking on gas here, guys. Cool. So, where we've got the Cinera, where are those database files? Get to the right database. Okay. It's the Cinera one. Oh, these are input 1. So yeah, we've already got a 4. We know the number of the things in the block. Just give us a couple of minutes. PJ Harvey's just finished an album, so I'll just be a couple of minutes and we'll continue with Tim Ecker. Alright, let's make a new block, which is going to be the database header. So there's a database Sinner header, let's make a database header. And this is going to have a unit, it's going to have a block ID, and it's like block count. So the block ID for the database header is going to be, let's make another init database function. Who actually is responsible for that? I think it's the Sinner function, isn't it? Yes, it is. There we go, init database Sinner. So, like equivalently, let's make consume jobs init. Sorry. What are we doing? Init database. Let's try this again. consume jobs now. Yeah, here we go. So consume jobs is going to say init database threading. And let's not do that. So yeah. Here we go. I think we called it that, didn't we? Yeah. Give it the 4CD of that. 4cc. And the block count is going to be 0 for starters. I mean, it will be, but let's just confirm it. And then we're going to want, within this database, we're going to want like an init block function. So we're going to want stuff like an init block, skip block. It's just those actually. Init block and skip block. Well, we can return a pointer to it, can't we? Oh, hang on. Yeah, actually we could use a get or init block. So we're going to be putting it in this database. I think, aren't we? And the actual block ID. So we're now in mib-h. I think that is actually fine. I think we don't really have an enum for the 4cc's. I mean, we don't really need a block ID for the top level, actually, to be fair. We could just say it's just the block count. Nah, let's give it. So we want a bunch of 4cc's basically. think it should be fine to just put them as a car array. So it's going to be we start at the start of the file. So the first thing that we see in a block is the 4cc. And I think a 4, let me just check what a 4cc is. Yeah, it's just a unit, they do. So the I think it's reasonable to just use that directly. Isn't it? Except for the fact that this won't. It is a pointer, but if you modify that, it won't actually properly modify it, I think. Well. Now, things I think you need to do that, maybe. Right, I think that's sufficient, does it? The thing is, though, if you do this, it will think it's, well, it doesn't. Interesting. So it expected a car start with dog music. Well, yeah, obviously. But yeah, the thing is, it was okay with both of those permutations, which I'm not particularly happy about. So what I'm going to do is I'm just going to say this, just to save sort of linguistic craziness. So we're going to do this. Yeah, we've got the block ID. Oh, sorry. This is going to be a number. Can I just do this? I've got a feeling I can't. Yeah, exactly. Okay, I think that should be right. So skip block, get rid of block. And I think we've managed to do all of that, I think. Haven't we? And if the result is still then we need to say let's increment the headers block count. Let's write out the existing database, and then let's write out the header for our block. It's basically this. And we're not going to sort the blocks. Because we don't mind. So we've got the database file, yep, the handle, that, the path, the location, back to right is this. We have to do all of this. F right that, this. That, and then that. So that is it. Sorry. That's nonsense. We need to actually give ourselves a block, don't we? So a scenario block is going to be a database scenario header. I feel like I'm doing this quite a lot actually, this. Yeah, the 4CC dance. Because what I'm basically doing is I'm doing this, aren't I? Yeah, in fact, it's just excuse me, it's just that. So that should be that, I think. Getter any block. Tag file database will be the bytes to write. Yeah, that still looks okay to me. Yeah, it does. And then return the thing. So who has called that exactly? Nobody's called it. Yeah, DB. So here we go. Except it shouldn't be that. It shouldn't just be get to write to database server now. It should actually be, you know, get block. Yeah, which is kind of interesting, isn't it? I mean, definitely we don't want to be doing the get rate database in there. So that's a definite no. What I'm going to do is I'm going to actually do a different function just for starters. And this function is going to take right into the database, the block. So we're going to have got the block, aren't we? Oh, it's just this. It's just this. Here. yeah. Here, rather than just saying that the header is straight up that, we just say get or init block and whatever that needs to take. Gosh, that is actually it, isn't it? So I'll tell you what, I'll take that back about removing that function. Yeah, I do take it back. I'm going to keep that the same function, and all we're doing is we're saying this getter init block in the database, and it's a BID etc. And this guy is going to produce an entry from the stuff that we've got. So the job that we've got is saying we need to copy, although for that, sorry, where is it? Job. Dude, it's just this, isn't it? It's straight up that, which is nice. Gosh, weren't we smart? Okay, and then similarly, where this previously was getting called, let's just null that out. Let's make this instead call push job. Except for the fact that we already have a push job, don't we? Yeah, so instead of, there we go, sorry. Instead of calling that there, we call this here. And then this guy, same as the other one, is just going to say get or skip entry, sorry, get or init block. And it's just that. So I'm probably missing a trick here. So that pushes the job. Probably missing a trick. But let's try it. If this works first time. Well, who knows what will happen. So there's threading DB. So there it is, thread and the 0 blocks. Now we're going to go to threading test. And we're going to make some jobs. Jobs for the boys. Jobs for the girls. Jobs for the boys, jobs for the girls. Oi. So that went through. Holy God, holy crap. So yeah, they've got this. There's now one block. Cinera and some jobs. I mean... what haven't we done here? Ah, we haven't nulled out the job, is that right? Ah, Cinera and Cinera, some jobs. So yeah, we've screwed up somewhere. Because we should have had two different things. I'm not seeing I mean in there. Okay. So yeah, take job. Appears not to be working, doesn't it? Yeah, I might want to step through some of this, I guess. Cinera and Cinera. Block ID strings, so Cinera use input. through, might be the order of the day. Let's just try something else. Oops. Aha. Oh, this is unfortunate. We've now got 2 Cinera blocks containing some jobs. Ah, it's just not finding the block, is it? That's all that's happening. To the, oh shit, that's a, yeah. We're trying to match a block ID against a 4cc. So get ID from 4cc, I guess is what it is, isn't it? Let's see what we've got in mib.io about that actually, or mib.h. Yeah, so it's this, isn't it? It's 4cc. Sorry. Isn't that right? Just 4cc is a 4. Sorry, a 4cc is a U32. So the block ID is the thing that we just got out of the thing, which is the 4cc, and the ID is the thing that's been pressed in. So we need to be saying if 4 with the block ID strings on the ID is equal to that. Yeah, I think that is more like what we're after. Gonna have to delete that file. So let's just reinitialize and try again. Yeah, that's great. So now I've managed to actually get the thing. Gosh, if that was the only bug, that's amazing. again, trying there, we got Cinnamon, amazing, yeah. And the jobs are being taken off the list, aren't they? Let's get yesterday's in. Ah, they're not actually. No, they're not being taken off the list. They were in this case. Ah, they're not actually being taken off. That's cool. That's good to see. By the way, I don't know if you can hear the vibrations coming through the mic, but I think one of my neighbours must have the washing machine on, and I can feel the good vibrations. Oh, hang on. Was it just that one of the... there's a push job. There we go. Yeah, that shouldn't have been doing the push job. That should have been lofted out to the outer person. That's awesome. So yeah, we're now back to an empty job queue. Back to an empty job queue. That's quite funny, wasn't it? To go empty and then 1, 2, 3, 4 lots of empty queue, it thought. So that could be wrong, maybe. Aha. Oh no, sorry. Yeah, this was okay. But it had a problem with what exactly? It's probably this file handle. Presumably it failed to open the file. Free the file path. Let's just try that again now that I've just made that small change. Because basically all it was it was this, and then saving this again. Not exactly sure what the case was. I might have to rewatch the video of what happened there actually. I can't quite remember what went on. Hang on, unless... Oh, it could have been that I'd written the file with Vim. We get the file system event. Saying that something is happening. But we get to here before like Vim has actually made that file again. Like it might delete the file and then write it again. Which means that we need to handle that. But maybe Sinner actually handles that already. The main thing that we want to have happening is for this spell to be being written. Oh god. So we've got... Yeah, right. So I think we just boo-booed it again. We've got two Cinera blocks. Well, I've got multiple Cinera blocks. Let's remove this. So yeah, let's stick it in a couple of... So that's twice that we've reset it. Cinera. Yeah, okay, so that's okay. That's still okay. Yeah, as is that. So we might be okay. We might be perfectly okay. Oh, it's not going to fit. We might be perfectly okay. Let's just try and do another cinera. Test. Oh. Now, is that just that again? It was that same place on the F-Seek, on the handle. I mean, it kind of seems, doesn't it, that we can just loop on this F open. Right? Like, I think that should save our bacon, shouldn't it? What's happened to the database at this point as well? Still looks alright to me. Yeah. Could be interesting actually to see how many times we could go through that loop. Couldn't it? Yeah, because we're not hitting that error now. And we're not like infinite looping either. So I think I'm just going to have a look at the file, and if it all looks in order, I think I might just call it a day. Some jobs. Ah, it doesn't look in order, does it? Because these guys are supposed to be in the cinera block. That's interesting. So I think the get or init block is just not quite right. Let's have a quick look. I think the problem is it's in either here or in skip block. And I'm also sort of skeptical about this casting actually, strangely enough. Although, I mean, it seems happy with it, so maybe it's right. Oh, hang on a minute. So it's the bummerneck. The void. It's a void. So I think I actually want to be using the pointer. Actually, that might be a bit more sensible. And then finally results. So I think, yeah, here. I think rather than using the result in all these places, I think what we want to do is this actually. And then finally, having done all of that, we just say result just to get to the pointer, and then we just return the result. I think that could potentially be necessary. So, yeah, let's just try and do that sort of thing again. Let's just try and recreate that. So we came in here. We made a file IO job, but we already had a job before that, did we? Unfortunately, we don't actually print it out. Should we have a guess that was a UI job? Because the thing is, we write a thing in that corner, and that probably overwrote what was actually written in there. Oh yeah, which almost certainly suggests that it wasn't a UI event. So UI event, then a file IO, then a file IO, then a file IO. Then we want to file IO again, I guess, although this is sort of saying this. Yeah, that looks more correct, I think. So I think the problem actually before, I think we had the Cinera. I do feel like we had the Cinera thing first. So let's just get rid of this again. Do this. Do this. Then do this. Now this. And finally. Yeah, I think something's still arise, isn't it? Yeah, we've got multiple UIPT blocks now. So by the way, this is nothing to do with threading here. This is just to do with writing to a blooming file. So I'm inclined to call it a day here. Partly because PJ Harvey and Tim Hecker have both finished their albums. Yeah, should we call it a day here? And then look into debugging this next time. And then after we've done all of this, I think we might be done with the multi-threaded mock-up system. And we might be on to moving on to stuff like the reference manager is one of the things. There's also stuff like the Cinero database, like sussing out the structure of that and adding more of our necessary stuff to it. So yeah, let's call it there. Let's call it here and debug this tomorrow, and then see where it all takes us. So yeah, anyway, thank you very much, heroes and heroines, and all other heroic people, for being here, for being amazing, for being graceful, and for, yeah, whatever. I'll see you the next time. Until then, farewell for now.